Welcome to the deep dive. Today we're tackling prompt engineering. You've sent in a ton of material, and it seems like you're ready to go beyond the hype and get to the real nitty-gritty. You want to understand not just what it is, but what you can actually deal with it.
It's definitely evolved. We're past simply calling it the hot new skill.
hmm
We're moving towards building complex systems around these AI models.
Which is why this deep dive is for you, even if you're not like a hardcore techie. Prompt engineering is about talking to AI, giving it instructions to get what you need, whether that's a killer app, snappier marketing copy, or just making AI tools work better in your daily life.
It's about understanding how to guide these models because it's not about total control. It's about working within their capabilities.
Okay, let's dive in. Looks like we're covering how these large language models, LLMs, actually work, how to structure a solid prompt, some advanced moves, and of course, the all-important testing and safety ready to get started.
Ready when you are. Let's start with the foundation. How do LLMs actually tick? You've got some great sources here that explain this core idea of LLMs predicting the next token.
Right. It's like our phone's autocomplete, but imagine it's read every book and website like ever written. We're talking prediction on a whole other level.
And what's fascinating is these models are stateless. Each interaction is a fresh start. They don't remember past conversations. We need to give them context every single time.
Hold on, if they're stateless, doesn't that make building something like a conversational AI really hard? How do developers even approach that?
It's a challenge for sure. Developers use techniques like storing conversation history externally and feeding it back to the LLM with each new interaction. Think of it like giving the model a cheat sheet so it can remember what was said before. It's a workaround, but it's becoming more sophisticated all the time.
Clever. So it's not true AI memory, more like giving it really good notes.
Exactly. This is where the structure of the prompt becomes crucial. And we see things like ChatML emerge. Think of it as a universal language for talking to LLMs, which OpenAI really pioneered.
And you mentioned that even ChatML is evolving. There's this model spec from OpenAI that hints at like future possibilities. Sounds like we're just scratching the surface here.
We are. Tools like TikTokenizer can be really helpful to visualize this structure. Seeing how the model breaks down your instructions can really help you understand what's going on under the hood.
Let's talk model features then. You flagged context window size, max output, and knowledge cutoff as important things to wrap our heads around.
Those are your practical boundaries when working with these models. The context window is essentially how much information the model can handle at once, both what you input and what it outputs. Max output is, as it sounds, the maximum length of the response you can expect. Then there's the knowledge cutoff, which is like an expiration date for the model's knowledge base. It refers to the most recent data the model was trained on.
So if I ask it about something that happened yesterday, it might be totally clueless.
It depends on when the model was last updated. Some models are updated more frequently than others. And this gets into the real-world considerations for developers. You've highlighted cost per token and context window size as big factors in app development.
Right, because a larger context window means more power. But it also costs more to run and can make things slower. I can see those trade-offs getting pretty complex.
Absolutely. There are also some really interesting capabilities emerging in models like GPT-4. Its technical report suggests it's becoming incredibly versatile with languages.
Oh yeah, I read about that. It's supposed to be able to understand and respond in a ton of different languages, right? That's got to be a game changer for global applications.
It has huge potential.
Hmm.
Though it's important to note that many of these models are still primarily optimized for English. So while their performance in other languages is improving rapidly, it's not quite at the same level yet.
Got it. So still room for improvement. So we've got these powerful LLMs. They're great at prediction, but we need to speak their language to get them to do what we want. This is where prompt engineering comes in, right?
Right. And it's more art than science, really. We're dealing with probabilities, not absolutes.
Yeah.
We can nudge the model in the right direction, but not force its hand.
That makes it sound way more challenging and interesting than just typing in a question.
It definitely is. Even with simple instructions, things can go off the rails. You had a great example in your notes about how a seemingly straightforward prompt caused the LLM to completely miss the mark.
Oh, yeah. The one where it failed to give a single answer because of a leading phrase, that was pretty wild. I mean, how can something so smart mess up something so basic?
It highlights how sensitive these models are to phrasing. A subtle change in the prompt can lead to a completely different outcome. In that example, the LLM got fixated on the way the question was worded and couldn't get past it, even though the answer should have been obvious.
So it's not just about being right, it's about being right in the way the LLM expects. That's a bit tricky.
It is. That's why testing is crucial. But before we get into that, what about those tools you found, the ones that give us a peek behind the AI curtain? You mentioned OpenAI Playground's show probabilities and a couple of others that caught your eye.
Right. The show probabilities thing is fascinating. You can see which tokens the LLM is considering at each step, like peeking into its thought process. And then there's Gemascope and the Mapping the Mind paper. Those explore how different content activates different parts of the LLM.
It's like mapping the LLM's brain, seeing which areas light up based on the input. And that ties into a concept called latent space activation that David Shapiro writes about. The idea is that we can trigger specific skills or knowledge within the LLM through carefully crafted prompts.
So instead of retraining the entire model, we're just activating the parts we need. Is that reliable, or are we just crossing our fingers and hoping for the best?
It's not about luck. It's about understanding the patterns in the data the model was trained on. By using the right language and structure, we can increase the probability of activating the desired skills.
Okay, so it's not just about what we say, but how we say it. So how do we craft a really powerful prompt? You mentioned a general structure in your research that we can follow.
Yes. Think of it as a blueprint for effective prompting. It includes 5 key elements: context, goal, rules, raw egg, and few-shot prompting.
5 elements. That's starting to sound less like writing and more like programming, but okay, let's break them down.
First, we have context. This sets the stage and avoids ambiguity. For instance, telling the LLM you are a JavaScript developer primes it to respond in a specific way.
So it's about setting expectations right from the start. And the goal element is about telling the LLM what we want it to achieve, whether it's a broad task or a very specific output.
Exactly. The rules element is where we define how the LLM should behave, how to handle things like insufficient data. This helps make its output predictable and consistent.
So the rules are like the guardrails to keep it on track. And what about RAG? I've seen that pop up a few times.
RA stands for Retrieval Augmented Generation. It's about bringing in external information to expand the LLM's knowledge base. For instance, if the LLM needs access to specific data or real-time news, we can provide that through RAG.
So it's like giving the LLM access to like a massive library to help it do its job. That's pretty cool.
It's a powerful technique. And then we have few-shot prompting, which is essentially teaching by example. You provide the LLM with a few examples of the desired output, and it learns to follow that pattern.
You even suggested including examples of both success and failure, so the LLM knows what not to do. That's thinking ahead.
It's about covering all the bases.
Yeah.
You also had that interesting XML-like prompt structure in your research. It was designed to get simple yes or no answers from the LLM.
I did. It showed how we can use formatting to really structure the prompt, even though, as you pointed out, that specific example was easy to override. Always room for improvement.
Absolutely. Which brings us to testing and the distinction between prompt design and prompt engineering.
Okay, so prompt design is about the instructions themselves, wording, structure, examples. And prompt engineering is about how those prompts are used in real-world applications. Is that a fair assessment?
Exactly. Prompt engineering involves testing, optimizing, and even chaining prompts together to create complex workflows. You might even hear the term flow engineering being used to describe this interconnected nature of prompts.
So it's not just about individual prompts, it's about how they work together like a well-oiled machine.
A great analogy. But let's not get ahead of ourselves. Let's focus on the prompt itself for now. You've highlighted some really cutting-edge techniques that go beyond the basics.
Yeah, I found some stuff that blew my mind. Like using keywords or external data to activate specific skills within the LLM. And then there's using examples, as we discussed, to guide behavior, even showing contrasting outcomes.
Those are powerful techniques. And there's also the idea of steering the LLM's behavior by providing specific content or even having multiple LLMs work together.
Multiple LLMs working together. Okay, now that is next level stuff. And remember that research paper, large language models are human-level prompt engineers. The idea that LLMs could actually help us write better prompts. Mind-blowing.
It is. And for anyone wanting to go deeper, you've got some great resources lined up. The prompting guide, the goal-oriented prompt engineering paper and its references, and the Fabric repository are all fantastic starting points.
And then there's the meta prompt, the prompt that writes other prompts. Talk about AI inception.
It highlights the collaborative nature of prompt engineering. We're working with these models, not simply giving them orders.
So it's a partnership, not a dictatorship. I like that. But it
Yeah.
seems like there's a whole taxonomy of prompt types out there. We've got zero shot, few shot, thought generation, ensembling, and a bunch of others. How do we even know where to begin?
It can seem overwhelming, but remember, these are tools in your toolbox. Zero-shot prompting is the simplest form, just an instruction with no examples. Few-shot prompting, which we've already discussed, adds a few examples to guide the model. Then there's many-shot, which uses hundreds of examples for when things get really complex.
And then there's thought generation, where we're trying to guide the LLM's internal thought process, either by providing a chain of thought or letting it come up with its own.
Exactly. Ensembling is about using multiple prompts or multiple runs of the same prompt to compare results and get a more reliable answer. And then there are techniques like self-reflection, where the LLM thinks about the task before giving an answer, and self-criticism, where it critiques its own output.
Although you did mention that research suggests self-criticism isn't that effective yet. But who knows, maybe that'll change as these models get even smarter.
It's a rapidly evolving field. And then, of course, there's decomposition, which is about breaking down complex tasks into smaller steps.
Like creating a recipe for the LLM to follow, step by step.
Precisely. And all these techniques can be combined in powerful ways. For example, you could use decomposition with a chain of prompts, or create an agent that dynamically selects which prompts to use based on the situation. That brings us to the need for modular prompts, especially when building applications. You had some great research on that.
Yeah, the idea that we need to think about how prompts work together in a larger system. You had that example of a memory map showing how sections of a prompt can be static or dynamically generated.
A good example of how modularity works in practice. And remember that code snippet you found. It showed how quickly things can get messy when you're trying to manage all those different prompt sections.
Yeah, talk about spaghetti code. It's a good reminder that planning and structure are essential. We can't just slap things together and hope for the best.
Exactly. So what are the key things to keep in mind when designing modular prompts? We need to give our listeners something actionable they can walk away with.
Great point. Let's talk about those considerations. Okay, so we're building an app or some complex system that uses LLMs. Where do we even begin with these modular prompts?
Think of it like designing a house. You wouldn't just start like throwing bricks around. You'd have a blueprint, right? So first, consider the overall structure of your prompt and how it fits into the application. Then you break it down into sections, figuring out which parts need to be reused or dynamically generated based on user input or other factors.
Makes sense. So it's not just about sticking pieces together. It's about having a strategy from the start. What about the nitty-gritty, like actually separating these sections?
The separators you use are crucial. They need to be unique enough that they won't accidentally appear in the content and confuse the LLM. And the formatting within each section matters too. Will you use lists, markdown, code blocks? Each choice can impact how the LLM interprets the information.
We need to be mindful of the LLM's attention span.
Exactly. The order of the sections can influence what the LLM prioritizes. Research suggests that information at the beginning or end of a prompt tends to carry more weight, though that could change as these models evolve.
Always good to remember these things are moving targets. So we've got the structure, the separators, the formatting. What else?
Think about how you'll incorporate few-shot examples. Will they be static or change based on the context? And most importantly, what role does this specific prompt play in your overall application logic?
Right. Is it a solo act or part of a bigger chain of prompts? And how will its output be used?
Precisely. These are all crucial questions when you're building with modular prompts. And of course, throughout this whole process, testing and monitoring are your best friends. Tools like LangFuse can be incredibly helpful for that.
Testing feels even more important here than in traditional coding. Because with LLMs, there's this layer of unpredictability. We're essentially collaborating with a black box.
You hit the nail on the head. It's not a set it and forget it situation. We need to constantly evaluate and refine these prompts to make sure they're behaving as intended. That's where a tool like PromptFoo comes in.
I'm glad you brought that up. Being able to test prompts against datasets and across different LLM models is a game changer. I even included an example of a PromptFoo test result in the materials. It really highlights its power.
It's a fantastic resource. We'll do a deeper dive into evaluation techniques in a later episode, but for now, I encourage you to explore PromptFoo or any similar tool that catches your eye. Start experimenting.
Consider that a call to action. Now, let's circle back to few-shot examples. We talked about their power, but you also emphasized that they're not a silver bullet. What are the traps we need to avoid?
It's easy to fall into the trap of thinking examples will solve everything. While powerful, they're not a substitute for good prompt design and engineering, especially for complex tasks. Plus, you highlighted how LLMs can drift from initial examples in conversational settings.
Yeah, like they get bored and start improvising. So for longer conversations, we need more than just a handful of examples.
Exactly. We need strategies to maintain consistency. But even with basic few-shot prompting, the quality of the examples is key. Aim for diversity. Cover both common scenarios and edge cases. And remember, the LLM is there to assist you, not replace your judgment.
That story you shared about the LLM generating unhelpful examples was a perfect reminder. We can't just blindly trust what it spits out.
Absolutely. Speaking of trust, or rather the lack of it, let's talk about precision. How do we make our prompts as bulletproof as possible?
Because even with the best design and testing, we're still working with probabilities, not guarantees, right? That inherent uncertainty of LLMs is something we can't escape.
Exactly. Observation is key. Logging and monitoring LLM interactions are the first steps in debugging. You provided a great example with that language translation prompt. It seems simple, but the LLM ended up treating part of the text as an instruction instead of something to translate.
Right. It went off script because the wording wasn't precise enough.
Precisely. So you walk through the steps taken to make the prompt more robust, adding ignore content instructions, and using few-shot examples to demonstrate the desired behavior.
So it's like training a very literal-minded assistant.
In a way, yes. But it's important to be realistic. No prompt is truly perfect. Sometimes LLMs are just not the right tool for the job, and we need to be honest with ourselves about that.
Knowing when to walk away is wisdom, and that brings us to something we can't ignore: security. You didn't sugarcoat it, stating outright that any information sent to an LLM is potentially compromised, even in secure environments. That's a bit unnerving. What are the biggest threats we need to be aware of?
Data retention policies are a major concern. We often don't know what happens to the data we send to these models. Then there's prompt injection, where malicious actors can manipulate prompts to get the LLM to do things it shouldn't.
That secret password example where the LLM was tricked into revealing it still gives me chills. That's straight out of like a hacker movie.
It's a classic attack vector. And then there's jailbreaking, where restrictions placed on the model are bypassed. And of course, there's the inherent uncertainty of LLM output. We can't always predict how they will respond.
So how do we protect ourselves? It sounds like we're walking a tightrope.
We need a multi-layered approach. Sanitizing user input is crucial, as is limiting LLM write access. Human oversight is essential.
Yep.
And we need to be skeptical of guardrail solutions. You mentioned Pliny the Prompter, who's made a name for himself by breaking through these supposedly secure measures.
It's a constant cat and mouse game. So as we wrap up, it's clear prompt engineering is not just a buzzword. It's a vital skill for anyone working with LLMs, whether you're a developer, a marketer, or just someone who wants to leverage the power of AI.
Absolutely. It's about understanding the strengths and weaknesses of these models and learning how to use them responsibly and effectively.
We've covered a lot of ground today: how LLMs work, prompt structure, advanced techniques, the crucial element of testing, and the ever-present need for security. What's the one thing you want listeners to remember from this deep dive?
I think it boils down to this. Think probabilistically. We're not in total control. We're guiding these models, influencing outcomes, and that requires us to constantly evaluate, refine, and experiment.
So get out there, experiment, test those prompts, and remember, this field is constantly changing. What works today might be obsolete tomorrow.
That's a great point, and it leads to a final thought for our listeners. Given how rapidly this field is evolving, what does the future hold for prompt engineering? Will it become more intuitive? Or will it demand even deeper technical skills? Will we see AI systems that create their own prompts, further blurring the line between human and machine?
It's exciting, a bit daunting, and we'll definitely be exploring it further in future deep dives. Until then, happy prompting.